that I cannot operate directly the slides. The problem lies, the main problems of this aspect of the pathology is the fact that ACE2 has two functions, enzymatic function and receptor function. As an enzyme, it is a key element of the renin-angiotensin system, and as a receptor, in addition to facilitating the entry of the virus into the cell, it can activate cellular responses such as platelet aggregation, cytokine production, and intestinal mucose dysfunction. Moreover, another key function is to metabolize bradykinin, which is a mediator of inflammation and pain. Today, we focus on the issue of the renin-angiotensin system. Next, please. Renin, produced by the kidney in response to hypotension and hyponatremia, splits the angiotensinogen molecule. I don't see the figure.
Oh, sorry.
We are discussing the renin-angiotensin system. Exactly. Thank you. The renin splits the angiotensinogen molecules at the lithium residue, generating the decapeptide angiotensin 1, which in turn is converted in the pulmonary capillaries to biologically active product angiotensin 2. Angiotensin 2 mediates most of its physiological function through the AT1 receptor, contributing to vascular homeostasis, but elevated levels are deleterious, causing vasoconstriction, coagulation, inflammation, and oxidative stress. ACE2 can cleave angiotensin 2 to generate inactive peptides and angiotensin 1,7, which as a receptor, MAS1, which mediates vasodilation, hypotension, diuresis. Next, please. Therefore, two so-called axes can be outlined in renin-angiotensin system. AC angiotensin 2 AT1 receptor from one side, and AC2 angiotensin 1,7 a MAS1 receptor on the other side. The two axes have opposite functions to maintain a balance of the whole renin-angiotensin system and the control of the circulation. AC2 exists in a form bound to the same membrane and also in a soluble form in serum. It's called SAA2. Both have enzymatic functions capable of cleaving angiotensin 2. The next one, please. Next one. As autoimmune disease in COVID has received attention, several studies have begun to examine whether SARS-CoV-2 and its vaccine can lead to autoantibodies production. To clarify the immunological aspects of post-vaccine syndrome, we performed a retrospective studies of a number of subjects cured by doctors of an institute, a clinical institute in Milano, where patients affected by this syndrome are cured. We studied a series of 31 subjects with these post-COVID-like symptoms, both vaccinated and not vaccinated. We extracted the medical records of 17 subjects which were vaccinated with mRNA or adenoviral vectors, were healthy before vaccination, had never been infected with the SARS-CoV-2 because they are negative with anti-nucleocapsid, presented the symptoms for a mean time of 20 months. The medical records of all patients referred to our clinic over a 1-year period were analyzed retrospectively. The next, please. Patients reported a minimum of 4 and a maximum of 15 symptoms, with a mean of 9 symptoms per patient. The most common symptoms were asthenia, memory concentration problems, headache, tachycardia, hypertension, other neurological symptoms such as neuralgia, paresthesia, fasciculations, widespread burning sensations, fainting, and visual disturbances. Skin alterations such as edema, rash, bruising were also reported by several patients. The symptoms were severe and persistent or recurrent over months of year. We have performed a series of laboratory tests. There is no time to discuss every point. It is important to know that of 70 patients, 13 had levels of interleukin-1 beta above the normal limit, and 11 had increased interleukin-8. Here I intended to focus on the main point of our discovery, which concerns the autoantibodies. Next, please. A commercial panel of 16 antibodies was used, including a series of antibodies against GPCR receptors and again 2 other receptors related to renin-angiotensin system and potentially involved in COVID-19 and vaccine responses. The panel of 16 antibodies was tested from frozen serum using commercial ELISA kit. The next one. The most frequently altered antibodies were those against MAS1, the receptor for angiotensin 1,7, ACE2, angiotensin converting enzyme 2, muscarinic cholinergic receptors, beta-2 adrenergic receptor, alpha-1 adrenergic receptor, and so on, as you see in this figure. Then the next one. We wondered if positivity to any of these antibodies correlated with symptoms. Of course, such a small series of cases is provisional, but the statistics have indicated a positive correlation between MAS1 with burning sensations and AC2 with bruising or skin rashes. Median anti-ACE2 levels in series of patients with bruises and edema and or rashes were 26 units per ml, while in patients without these symptoms, serum levels were 8.4 units per ml, a difference which was statistically significant on man-Whitney test. Also, for MAS1, we found a correlation with some symptoms, namely widespread burning sensation. Anti-nuclear antibodies, anti-neutrophil cytoplasmic antibodies, and anti-cardiac muscle antibodies were negative. Next, please. This is a figure of bruising or skin rashes, which were present in 8 patients from the group of 17. All these patients were positive for anti-AC2. Next one. In this histogram, you see the symptoms reported by patients negative for AC2 in blue or positive for AC2 orange. The ACE2 positive patients had a higher percentage of symptomatic cases, and the difference between positive and negative cases is particularly evident for hypertension, headache, gastritis, skin bruising, skin edema or rashes, thrombosis, and lower risk of vision. You see the difference between the orange bars and the blue bars. For some symptoms, only ACE2 positive patients were present. The next, please. In a recently observed case in our outpatient clinic, not included in the previous studies, the increase in anti-MAS1 was particularly marked, represented by far the greatest deviation when compared to the other antibodies of the autoimmune panel we used. This patient is a 55-year-old woman who had always been in good health until the onset of post-COVID vaccination illness. Vaccinated on March 2021 with the viral vector vaccine AstraZeneca, she initially experienced arthromyalgia and low-grade fever, which resolved with paracetamol. After 3-4 days, erythema appeared in the face and the trunk. In the following weeks, months, she experienced worsening of erythema, itching, widespread arthralgia, and widespread burning paresthesia. She had also several hypertensive crises. These symptoms persist with alternating severity, documented by repeated medical visits. The patient is undergoing antihistamine therapy, cetirizine dihydrochloride, with partial improvement, while steroids appear ineffective. The next one. We try to develop an hypothesis on the mechanism of formation of these autoantibodies. Autoimmunity is a complex and multifactorial phenomenon, so various mechanisms can come into play. Genetic background, adjuvant effect of lipid nanoparticles, molecular mimicry, and anti-idiotype antibody. I focus only on the last 2 points, please. The next, please. Okay. The molecular mimicry is one of the most investigated mechanisms, and there are several papers showing that spike protein has similar sequences of amino acid sequences and conformational assemblement of the protein with the part of other protein of our body. For example, TQLPP motifs in spike a similar similarity with the thrombopoietin, and ELDKY is shared with the, for example, protein kinase involved in platelet activation. And in any case, you can find several papers on this possibility, but this does not explain completely the presence of autoantibodies against ACE2 and MAS1. So the next one, I show the concept of the anti-idiotype. The idiotypic network represents one of the most important immunological theories. This concept, developed by the Nobel Prize Niels Jern at the end of the last century, is based on the idea that the idiotype, that is the region of antibody that binds to the antigen, can be recognized by the immune system as a foreign protein, and consequently can trigger the formation of antibodies that are called anti-idiotype. Idiotypes can be considered foreign and immunogenic protein. According to the immune network theory, in response to vaccination, a network of clones between anti-idiotypic antibodies and T-cell receptors is organized. This network can generate a large series of anti-idiotypic receptors and antibodies, which broadens the repertoire of epitopes. This phenomenon is called epitope spreading. Some antibodies emerging from idiotype network and epitope spreading can have functional effects on their target proteins or receptors. The next one, please. So this figure summarizes the formation of anti-idiotypes in COVID vaccination. In the best case scenario, as illustrated in the upper part, the vaccine induces the production of the S protein, which stimulates the immune system to generate specific antibodies against it. These antibodies neutralize the virus, preventing its interaction with the ACE2 and reducing the likelihood of infection. This is the desired mechanism, which ideally should provide at least temporary protection after vaccination. However, a problem arises when these same anti-S antibodies, instead of simply neutralizing the virus, bind to the S protein expressed by the body cells. They can thus attack the very cells that produce the S protein, as in the case of cardiac cells, and produce cytotoxicity. This phenomenon represents one of the main critical issues with this vaccination strategy and constitutes a serious conceptual flaw in the design of these vaccines. In the lower part of the figure, the formation of idiotype secondary antibodies is outlined. AB1 idiotype is recognized as a new antigen and AB2 antibodies are produced. This mechanism does not represent a pathological condition per se. On the contrary, it is a physiological phenomenon of immune self-regulation, useful for balancing the presence of antibodies and preventing excessive production of new immunoglobulins. However, the next please. However, the problem of potential pathology arises from the fact that these AB2 antibodies, being capable of binding to AB1, which is capable of binding to the spike protein, are in some way a mirror of the spike protein itself. That is an internal image of the spike protein and therefore shares some of its molecular binding capacity against the ACE2. The next, please. One possible scenario is the following. When the production of anti-S antibody becomes excessive, which refers to a condition of immunological overload, the immune system responds by generating large quantities of anti-ACE2 antibodies. However, the critical point is that they can interact with ACE2 receptor, the same one that represents a target of the viral S protein. As a consequence, ACE2 enzyme function can be blocked, leading to increase in angiotensin second and bradykinin, which can cause many of the disease symptoms, as we have seen with the spike protein itself. However, the problem here is that while the spike protein is eliminated in most cases within a few weeks after vaccination, the autoantibodies persist and the disease can become chronic. The fact that the doses of anti-ACE2 are correlated in our study with the amount of anti-S is in agreement with this hypothesis. The next one. Very recently, the importance of anti-idiotypic mechanism has been confirmed experimentally with the evidence that the administration of the anti-SARS-CoV-2 vaccine to transgenic mice for the AC2 receptor is followed by the formation of autoantibodies, and the phenomenon is greater with repeated administrations. The next, please. Finally, this figure summarizes the functioning of the RAS and the main point where the three different types of antibodies can act. With regard to AC2, if the antibodies block the activity of the receptor carbopeptidase, this could lead to increased angiotensin II levels and subsequent activation of AT1 receptor. This activation might lead to hypertension, pro-inflammatory effects, endothelial dysfunction. Considering the MAS1 antibodies, these antibodies could block the MAS1 receptor and prevent the beneficial action of angiotensin 1,7. The next, please. So this mechanism leads to increase of this axis and disruption of the system's equilibrium, with significant consequences due to the lack of the anti-inflammatory and anti-hypertensive axis. The case we described also highlighted the probably pathogenic effect of MAS1 receptor deficiency on the sensory and autonomic system. We cannot say that this is the cause of all the symptoms, but it is clear that in our experience, these strong changes of the autoantibodies levels are among the most evident changes repeatedly found in this kind of patients. The last one, please. Finally, I want to end by thanking Matt and Joseph, who had the expertise and courage to bring these problems to the attention of the medical and the scientific world. These patients, these unfortunate patients, must be recognized and supported in their own best interests and in the best interests of medical science in general. Looking ahead, we can hope that the discovery of this important molecular mechanism of autoantibody type damage can help the diagnosis, if it is proven to be a reliable biomarker, and hopefully also the clinical follow-up of this severe disease. I'm not a clinician, but I'm a pathologist, so I've focused more on the mechanism than on the treatment of the disease. One thing is certain, however, understanding this phenomena can aid in the diagnosis and follow-up of patients with these post-vaccine syndromes. Thank you very much.
Thank you very much, Paolo. Yes.
Sorry for my English.
Oh, no worries. Yeah, we'll just open it up open up the field for questions now, but I'll start. It's basically two questions. What are the extensions of this work? How can you take it further? And also, what are you working on right now?
The extension is to continue to follow patients that come to the clinic I'm not a clinician, but there are 2 or 3 doctors dedicated to this kind of disease, because the Milano Institute of Medical Biology is one of the most important in Italy, and there are few of these centers. They collect more cases. They are also trying to find some drugs that can help these patients. For example, they use in most patients they use glutathione, and they use flavonoids like asparagine and quercetin, and then they also use, if needed, antihistamine, or they can also try in some patients the use of angiotensin 1,7 that can be prepared by the pharmacy. Unfortunately, we must say that at present it is almost impossible to perform double-blind clinical trials, because the patients come to the clinic for the cure, and the clinic is not able. There are not support. There is no support from public support, and so it is practically impossible to perform clinical trials. So at the present, they are in situation of observational studies, and also this is also very important to increase the number of observation, because it is necessary to subdivide this syndrome in different sub-syndromes. For example, there are some patients with neurological problems, other with more cardiovascular problems. You understand? But the very important, one of the very important steps is to convince the Italian health authorities to recognize the syndrome, and to give to patients the possibility to perform diagnosis and follow-up under the cover of the national health system, because some of these analyses are very expensive, and these poor patients sometimes must spend a lot of money just to do analysis without any clear result.
Okay, thank you for that response. We have a question from the audience. Will these findings be incorporated into clinical guidelines?
Excuse me?
Will these findings be incorporated into clinical guidelines for, say, diagnosis?
Yes, this is very important. If this analysis would cost less, and it will be available in any laboratory, I think that this kind of antibodies should be measured in any patient, because as you have seen, even in a small group, the alterations are very frequent. But the other types of autoantibodies are found only in a few patients. So this is very, very important. not all the antibodies are important. Till now, we found some antibodies which are not correlated with the symptoms. But this is very, very important to increase the number of observation, and an international cooperation will be welcomed.
Okay. I have another question. Between patients, would the structure of these anti-S or sorry, these autoantibodies to the spike protein, would the structure generally be consistent from person to person, or could it vary?
The anti-S antibodies are, of course, present in all our patients, but with the high variability. For example, in some patients we can find 100 units, but there is some patient with the thousands of units. The important thing is that we have found a correlation between anti-S and anti-ACE2. As more as anti-S are present, as more anti-ACE2. This is consistent with the hypothesis of anti-idiotype mechanism.
Okay.
The problem, of course, is that anti-S antibodies are triggered also by the viral infection, and vaccinated patient can come in contact with the virus, and the disease can show flares, can have new manifestation, new clinical derangements due to the infection with the SARS-CoV-2. And SARS-CoV-2 does not cause serious disease per se. But in this kind of patients, even if the COVID-19 is not serious, the autoimmunity can be increased. You understand the problem?
Yes. On that, do you think there's a similar mechanism behind long COVID?
Yes, I think it's very, very similar mechanism, very similar symptoms. Of course, the initial triggering is a bit different because the spike protein is not exactly the same. Molecularly speaking, the spike protein of vaccine is some way different. So it is possible that triggers in different patients, according, for example, to HLA polymorphism, can trigger different disease. Maybe in some patients, only the vaccine can cause the disease and not the virus. Vice versa, in other patients, the virus can trigger the long COVID, and the vaccine can protect.
Yeah, there's the literature on the protective effect of vaccination for long COVID. It in population studies you tend to see that there is some protective effect. but a certain percentage of people are actually get worse as a result. So that variability is quite interesting.
Yes, unfortunately, the long COVID is much more recognized by the medical community, but the post-vaccine syndrome are neglected.
Yes, yes, yeah. That's very very important, and thanks for yeah. Thank you for highlighting.
I don't know if also in the United States it's the same.
I think it's pretty much the same globally. As far as I know, there's not a jurisdiction which has looked into this openly. So yes, I'll just ask any more questions? Anybody? If not, then we will conclude. Thank you very much, Prof. Bellavite. We appreciate you taking the time to give this lecture to inform us about your valuable work, and we thank you for looking into this honestly and scientifically. So
thank you to you. Thank you to you, and have a good day.
Yes, thank you. I will close the meeting now. Goodbye, everyone. Have a great day.